Welcome to Tetrionics. In this lecture we'll be covering the quantum geometries of mass, energy and matter and relating it to charged matters in motion. Specifically, this lecture will cover the foundational geometries relating to special relativity, where we'll expose the weaknesses in special relativity, and we'll re-express Lorentz's calculations and formulations in terms of equilateral geometries. In doing this, we'll obviously reveal how special relativity is built on an erroneous foundation, and we'll correct this foundation using the equilateral geometries of mass, energy, matter, and the motion of matter through space. All the material in this lecture is available in Tetryonic ebooks, specifically books 1 and 2, Quantum Mechanics and Electrodynamics, and there'll be an additional lecture further in the series where we'll cover general relativity. This lecture specifically refers to special relativity. The foundation of Tetrionics is the equilateral mass-energy geometry of Planck's constant. This has been discussed in previous lectures, but we'll go through the finer points in this particular lecture, and we'll highlight how it all relates to specific notions and formulations with respect to special relativity. Obviously, the first point that it differs from with respect to special relativity is that Tetrionics formulates mass energy as equilateral geometries, whereas Tetrionics has no specific relativity has no special geometry for mass and energy itself, but it relates more back to spherical charged geometries and again spherical regions of space. Mass, energy and matter itself within relativity is expressed in terms of the stress energy tensor, where all forms of energy are lumped together and expressed as an energy density variation within any measured region of space. This is often referred to as space-time. However, in Tetrionics, we'll in fact show how space-time is not the term that it's thought to be, i.e. it's not a measure of energy, it's a measure of the charged geometry of energies within any region of space. Einstein was the first to point out that obviously any major breakthrough in science by necessity involves a complete re-evaluation of the accepted theories and hypotheses of science itself. Where current theory runs into roadblocks or has mysteries or unsolved paradoxes, it's obviously an indication that the theory itself is lacking in one form or another. Science over the last 300 years has been built on the foundation of mathematics, and while the mathematics accurately models the observed physical properties of mass, energy and matter, and has been successfully used in many cases to extrapolate new and additional properties, it has failed on a fundamental basis. Tetrionics differs from the mathematical formulation of physics in that it's a purely geometric formulation. From this geometry, we can then derive the mathematical equations that are expressed in the mathematics as currently understood, and we can use this geometry to provide a fixed extrapolation from known formulations. Again, the geometry itself can provide a rigid structure where the logic of mathematics itself fails. It's often described, or math is often described as being the language of science or physics. In this case, it would be best to describe Tetrionic geometry as the grammar for that language. It's that the mathematics itself, as we currently formulate it, is simply a human wording or expression of the underlying geometry. The mathematics itself has to follow the geometry because it is the geometry itself that is creating the physics. In the case of Tetrionics, we'll show that the underlying geometry is of course equilateral. This allows us to make a choice between using mathematics and continuing on our approach where we have a number of erroneous features such as black holes, etc., and statistical probability mechanics where there is no finite or deterministic outcomes to quantum mechanics itself, or we can choose the geometric approach where the geometry itself determines what interactions are possible and what mathematical extrapolations should be allowed or disallowed based on their geometries. Of course, there are a number of misleading physical properties that Tetrionics will set about rectifying in order to explain or redefine physics in terms of special relativity. The first and most fundamental one is the fact that square units of measurements, be they energy, area, etc., are in fact not necessarily square geometries. And in fact, in the case of Tetrionics, they are equilateral geometries, or more precisely, equilateral triangles. Obviously, the term equilateral can refer to squares and hexagons, just the same as it can refer to a equilateral triangle. It's just a curiosity and a weakness of our use of English language with reference to the mathematics, that sometimes our descriptions in English are not always as robust or accurate and well defined as they are as the mathematics. And equally, we'll show that the mathematics, without an understanding of the underlying geometry, can also generate spurious and erroneous assumptions. In Tetrionics, we define free space or empty space as a region defined usually by a measurement of time. We can make this measurement in a number of ways. It can be a spherical measurement, it can be a planar measurement, or it can be a Cartesian measurement, a cubic measurement. In each case, what is being defined in the case of free space is any area or volume as defined by the measurement of time with whatever geometry that creates, that is free of energy in any form, be it mass, be it radiant energy, or be it matter. The absence of energy in all its form is what is termed empty or free space. By defining the area of measurement using, for example, the natural velocity of energy, or c, the speed of light, we can then determine a bounded region within any volume of free space where we can measure the physical properties of energy of any system. In the example shown here for 3 dimensions, obviously the term 3 dimensions comes from the Cartesian geometry or coordinate system, x, y and z directions. In this case, if we were to measure this in terms, or define this in terms of the natural velocity of energy, we would in fact have either a Cartesian coordinate system or it would be defined as c cubed. You will find in relativity, in special relativity, most of the measurements are c squared or planar Euclidean measurements of mass energy. and measurements of matter, more formally referred to in general relativity, will be noted as being c to the fourth. Again, the c to the fourth denotes positive and negative horizontal and vertical axes within a spherical geometry as opposed to a Cartesian geometry as shown here. Whatever method you use to measure and whatever velocity you choose to measure your time units in, the definition of, or the defining of the volume of measurement will of course determine the geometry of what you're measuring. As we mentioned, the natural velocity of energy, c, will give us a linear measurement of just under 300 million meters per second, as shown here. Equivalently, if we were to measure it in terms of the radiation of light energy, or photons, it would involve a c squared, or produce a c squared measurement per unit of time, because light itself, or photons, EM waves, radiate bilaterally in two different directions because of their charged geometries, positive and negative. So instead of having c, in the case of a charged geometry radiating in one direction, we have two charged geometries, which of course per second will produce c squared. Again, you can see in this case that we have a measurement of radial square meters per second as opposed to equilateral square meters in the case of the energy itself. So measurements of mass energy within units of time produce equilateral geometries per radial measurement of time. Again, as we've just mentioned in the previous illustration, if we were to define our physics system, or the measured system, in terms of Cartesian coordinates, we would have c cubed for our units, or our volume of space. And in the case of spherical measurements, we have c to the fourth. You'll see these terms, and as a general rule, where you see c squared, we're referring to mass energy geometries, or planar Euclidean geometries. And where you see c to the fourth, we are in fact referring to spherical coordinate systems, or measurements of matter. There is an overlap between the two. The most common two you'll see is c to the fourth and c squared. But when we start talking about force itself, you'll see in fact that these are the preferred units, as they'll rationalize each other out in the terms of force measurements. Just another representation of the measurements, or the spatial geometries or coordinate systems. Obviously a vector is a one-dimensional vector of force, or a measure of distance travelled per unit of time, or momentum. Various units use this same vector illustration. In the case of a measurement per second, we have per c squared, Cartesian coordinates again, and the spherical geometries I've previously mentioned. Again, these are all measurements of empty space, and as a measurement of empty space, they produce no results until we have energy in one of its three main forms within this region, defined by the unit of time, to give us measurements of either energy or mass or matter. Again, as we've mentioned, Tetrionics defines energy as an equilateral geometry of either positive or negative charges. As this energy radiates out from a point per unit of time, obviously the radial geometry created by the increasing units of time create ever-increasing concentric or circumscribed circles, and the energy follows this as well, as a direct relationship between the time measurement and the energy content of that physical system. In the case of energy per unit of time, we obviously have a mass-energy equivalence under Einstein's formulation of E equals mc squared, again m being lowercase m for mass. So we can say, in brief, that the equilateral geometry of energy is in fact the inverse of the radial geometries of time measurements, be they Euclidean or spherical measurements. And of course, in the case of spherical measurements, we're measuring matter, and instead of a equilateral geometry, we would in fact have a tetrahedral geometry for the standing wave form that is called matter. Quickly touching on Planck's constant again for those that are new to the section or haven't looked at the earlier lectures. Tetrionics defines Planck's constant as being a measure of mass and angular momentum. Again, mass being energy per second, as illustrated here, and indicated with a small m for mass. And quantized angular momentum, always designated in Tetrionics as alpha, is of course the equilateral geometry of the energy itself. So in this case we have mass energy contents, and we have quantized angular momentum along with the electric permittivity and magnetic permeability of the fields, giving us a charged Planck quanta. Again, the unified field equation within Tetrionics defines Planck's constant as mass alpha, and you'll see this in formulations for energy such as mass alpha nu squared. Of course, the important point to take away from here is that it's the equilateral geometries of energy that gives us square meters per second, whereas radial measurements of time give us square meters as an area per unit of time. So we have a clear contrast here between classical interpretation of quantized of angular momentum, which is a vector rotation about a point in one direction or the other, whereas Tetrionics now redefines this as quantized angular momentum to distinguish it from vector rotations, and shows that it is in fact a measure of equilateral geometries. So obviously, apart from the equilateral geometry itself, Tetrionics will now differ from most current textbook formulations of relativity so far as geometry, in the fact that the current textbooks show most of the relationships between mass, energy and momenta and kinetic energies as being or through right-angled triangle geometries, when in fact Tetrionics now reveals them to be equilateral geometries. Again, the formulations give the same answers for the math. No, I will correct that. The formulations in most cases will give the same answers for the math, but there will be some subtle but important distinctions. In this case, the important distinction is in this relativistic formulation of mass energy momenta. And in this case, this is one of the prime examples where Tetrionics shows that in force equations, this formulation is in fact wrong. You will note that in Tetrionics, because of the geometry, where we have velocity resultant from a force applied through the energy momenta of that force, resulting in the velocity, as I said, proportional to the mass, or the linear momentum of the system, the quanta required that the force applies to the system is always in square numbers. So it's the equilateral geometry in this case that maintains the relationship between mass, energy and linear momentum, along with the quantized angular momentum. You could in fact say that the linear momentum is in fact the square root of the quantized angular momentum, or the energy quanta of the system, Again, they're all different forms of mass, energy, momenta within the physical system. Newton, of course, formulated most of his laws as changes in momenta within a system. Tetrionics now shows this geometry and the relationship between classical formulations of mass, energy and momenta to the quantized energy momenta of the system. In this case we have mass velocity squared equals the energy of the system from the equilateral geometry, and that of course when you divide it by Planck's constant or equilateral geometries will always have a square number of quanta. Where you see h nu squared, you know you're speaking of energy, scalar energies. If you were to see h nu, you would in fact be referring to the transverse bosons within the system. And equally, if you see mass velocity, you know you're referring to the linear momenta of the system rather than the quantized angular momentum of the system, which of course is alpha. Again, all formulations of energy within Tetrionics take the form of mass alpha nu squared, which of course can be read as Planck's constant by quanta squared for the scalar field, or again the mass velocity squared of the field for the classical scalar energy of the system, with momenta being the square root of scalar fields. You'll find pi radians popping up throughout physics, or you'll find pi popping up throughout physics, and of course they refer to pi radians. This is where Tetrionics begins to take a whole new, or produce a whole new geometry compared to that of the classical formulations of relativity and classical quantum mechanics and mechanics itself, in that whereas Gauss's formulations and Maxwell's formulations, Coulomb's and even Einstein's relativistic formulations all refer to 4 pi as being a spherical geometry, we can now of course show that 4 pi geometries can in fact form either Euclidean mass energies, or when folded can create tetrahedral standing waves of energy forms, which of course are matter. Of course there's many different geometries that can be produced, but in all cases within Tetrionics, where you see pi in the standard mathematical formulations, it more than likely means pi radians, and they can be equated backwards and forwards. In the case of Coulomb's force laws, the 4 pi refers to superpositioned E fields, 2 pi by 2 pi, giving us 4 pi. In the case of Lorentz force, we're referring to the pi geometries of the magnetic fields within the total energy field. Obviously, again, you can see here in Einstein's formulation, we have c to the 4th, where we're measuring we're defining per unit of time the spherical coordinate system used to measure the mass energy matter content as a stress energy tensor. Here it's T. This energy tensor has all the mass, energy and matter equilateral geometries within it, all lumped together and defined as just an energy gradient within a spherical coordinate system. And again, where you see Planck's pi as a reduced Planck's constant, for example, or other formulations within quantum mechanics itself, you can now immediately look at a EM field of a pi geometry with electric and magnetic and redefine it as a 4 pi, where half of the field is an electric field and the other half are 2 magnetic fields, 1 pi each, giving us 2 pi again. So the magnetic field, the magnetic moment, is equal in strength to the electric field within the charged geometry. So if we wish to specify just the electric field component of interaction, of course we would just refer to the pi divided by 2 pi, or Planck's, in the case of equilateral geometry, that's Planck's constant. So Planck's constant divided by 2 pi gives us the reduced Planck's constant. Again, you'll see this time and time again, where the current formulations that are assumed mathematically to represent spherical point particles or spherical geometries are in fact equilateral geometries, and they can in fact just be substituted one for the other, with the obvious change in fundamental geometry occurring. This of course brings us to a different mathematical formulation of how square numbers form within physics, and what we have here is the standard Tetrionic table for mass energy. We have odd-numbered transverse bosons, which when they combine in sequence gives us the square energy levels of all mass energy. Obviously the square roots, or the heights, the amplitudes of these EM waves of mass energy, is the linear momenta of the mass energy system that's being measured. And these all follow integer numbers as per quantum mechanics. They are all quantized integer numbers, however they're measured. But in the case of transverse bosons, we have odd numbers, longitudinal measurements of photons. We will have even numbers, forming a bell curve or a normal distribution of energy, mass energy. And of course these all add up to square numbers within the measured physical systems. Again, just another rehash of the same illustration that we just previously saw, only in this case we've now mathematically defined odd-numbered bosons as being 2n minus 1 integers, and we've defined square numbers as the sum of 1 to n, where each individual quanta is a odd number. So obviously this is referring to the summing of the odd-numbered bosons, or the quantum levels, to form a scalar mass energy field. You can also refer to the summing as a integration of the bosons into the mass energy of the EM field. Of course, within Tetrionics we can now obviously highlight Planck nu, or n-pi geometries of Planck nu, as being bosons or charged geometries, and we can also specify n-pi h nu squared as being the scalar energies, again noting the distinction between nu for bosons and nu squared for scalar energies. Within Tetrionics itself, Planck's constant forms the basis for the quantization of all mass energies, or planar mass energies. In this case you see here that Planck's constant itself has two sides. You can consider it a equilateral quantum coin, where one side is positive and the other side is negative. If you were to cut these illustrations out and place them back to back, you would in fact see that the flux, or the classical view of quantized angular momentum, alpha, in fact rotates in the same direction in both cases. It's just our perspective, or our coordinate system that we measure the energies in, that determines whether it's positive or negative, depending on the orientation of the magnetic poles within the dipole of the field. Of course we can use this geometry in a number of ways, but in all cases the reality is it's the quantized angular momentum, or the alpha, the equilateral geometry, that is in fact the angular momentum of the system. There is no vector rotation about a point as it's drawn here. It's just a handy illustrative aid to understanding positive and negative charges in terms of classical formulations of angular momentum, and particularly within electrical systems. This becomes important in understanding the genesis of inertial mass within relativity. Obviously, these charged geometries can now interact via their magnetic dipoles and their charged E fields, and in doing so they form from bosons they form photons, and then they can form matter itself. Of course, each matter geometry being comprised of equilateral charged mass energy fascia, and the mass energy itself is in the form of a standing wave tetrahedral geometry, a tetryon. So the minimum quanta of matter itself, referred to as a tetryon in Tetrionics for its tetrahedral geometry, is a standing wave which takes up 3 dimensions, and it's made up of charged fascia of mass energy, and they're equilateral. Adding these charged tetryons together, or in some cases neutral tetryons, we form various charged geometries. In the case of 12 pi, or where 3 tetryons come together, we can form quarks and leptons. And where 9 tetryons come together, we can form baryons. Again, some are charged, some are neutral, dependent on their charge arrangements of the mass energy within the matter geometries. But in all cases, they are tetrahedral geometries, hence the name Tetrionics for mass energy and matter. Of course, this is in stark contrast to the current understanding of charge and point particles within quantum mechanics and electrodynamics, where they're viewed as spherical objects based on their 4 pi Gaussian charged surfaces. Of course, 4 pi Gaussian charged surfaces, or spherical geometries, can always be related back to 36 pi charged geometries by 4n pi, 4 being a multiple, or 36 being a multiple of 4, 4 being a factor, and 4 remains a factor in all matter geometries. So we can in fact generalize matter as being 4n pi charged geometries. Again, this obviously relates back to larger scale matter, where we're measuring charge in the case of Gauss for spherical geometries, but we can use this to show that the spherical geometries of macro scale matter are still made up of 4n pi or n 4 pi tetryons. So the quantum geometry is tetrahedral versus spherical for these particles. Tetrionics also distinguishes one from the other by saying that the mass matter geometries have a specific quantum charge, or quantized charge I should say, reflective of their Planck quanta, which gives us the charge of each fascia, and that the final particle, elementary particle, or even sub-elementary in the case of quarks, will have a net elementary charge, or just a single charge as it's normally referred to in Tetrionics. Again, this charge is the result of the addition of the various charged fascia of each tetryon as it comes together to form each form of matter, or fermions. Again, it's the equilateral geometry that gives us this explanation and understanding of mass energy, and the finer geometry of all particles and how they come to be formed, versus a generalized spherical geometry as derived from the mathematics that's currently been in use. As we mentioned, with Planck's quanta, or the quantum of action, in the case of mass energy, it forms the fabric, if you like, of all matter particles. As we increase the mass energy content of all matter, we increase the number of quanta in square numbers within the charged geometry of each fascia. Of course, they increase by bosons, or odd-numbered quanta, and they form square-numbered geometries. But in all cases, Planck's constant gives us a relationship between the scalar energy of the field, its equilateral quantized angular momentum, the equilateral geometry, and its mass. Of course, this has not always been expressed this way, but it's shown up in the mathematics as mass quantized angular momentum, or kilograms square meters per second. And of course, however many of these quanta per second are there, gives us our scalar measurement of joules, or kilograms square meters per second squared. With the equilateral geometry of Planck's constant now being shown in terms of the quanta that make up the mass energies of each charged matter particle, we can now, of course, show that it's charge that gives us these geometries of both mass energy and matter itself within physics. Planck formulated his equation for the heat law as energy equals N Planck quanta NH nu. Tetrionics re-expresses this obviously as a boson, as the as the energy content of a boson, or a transverse odd number of quanta, as illustrated here in orange. And we of course re-explain Planck's constant in terms of mass alpha. With the current formulation of quantum mechanics, the formulation for 0-point energy is in fact a half frequency, half HF. Tetrionics now reveals this geometry to be a boson of single quanta, in this case, a positive or a negative charge, dependent again on its measured properties, and we express this as h nu. But in the case of a photon of energy, which has a frequency where a positive and a negative are joined, or a frequency set, quanta set, obviously a single frequency is shown to be made up of two quanta, positive and negative, in order to create the photon. Again, this gives us a clear distinction in terms of mass energy between the geometries and characteristics and physical properties of bosons and photons. They are both mass energies. In this case, if there was two bosons, they would have the same mass energy as a single photon. But they are distinctly different charged geometries. In the case of bosons, in this case, there is 1 pi geometry versus 2 pi or tau geometries for the photon. Obviously, mathematically, 1 does not equal 2, nor does 1 equal 2 geometrically. They may have the same mass energies and the same linear momentum and the same quantized angular momentum as each other, and even the same electric permittivity and permeability properties, despite the orientations, as each other, but they are distinctly different particles and charged geometries. In this case, it's the geometry that reveals the differences between bosons and photons, whereas the mathematics doesn't. And in fact, there is a common problem within physics where the energy of spectral lines is expressed in Planck quanta, and this is equated directly to Planck frequencies. If you take Planck quanta as not being bosons and just being a general statement of any number of quanta equals a square number, this can be true. Or any number of quanta can be the frequency, this also remains true mathematically, but is not correct geometrically. Again, 1 does not equal 2, where you're referring to bosons and photons. You can in fact, make Planck quanta equal Planck F, Planck frequency, simply by doubling the number of quanta on this side of the equation. But it's completely incorrect to say that the number of quanta equals or is equivalent to the photon frequency. This equating of frequency to quanta has led to a number of misconceptions about the geometry and the nature of spectral lines. and in fact of energy itself within the atomic nucleus. So the charge field themselves obviously have to generate their charge from somewhere. Where we can say that it is the result of their equilateral geometry and Tetrionics, we can obviously model the flow of energy to represent this charge as a vector rotation in one direction or the other within the equilateral geometry. Again, noting that there is no physical rotation of energies. The electric permittivity and the magnetic permeability are strictly the result of static EM fields, geometries, within the scalar field itself. As we add more and more Planck quanta to a system, or increase the quantum number by the addition of bosons, we increase the mass energy within the field. And in doing that, because of the equilateral geometry of the scalar field, an imbalance is always created between the number of positive charges and the negative, well, positive quanta, and the number of negative quanta. Adding up the individual charges of the quanta within a field will show us the net charge of any field. And again, it will always be either positive or negative, except in the case of photons, where we have 2 pi geometries, and the positive and negative equalize each other out. But again, so far as the net charge of fields, mass, energy, and matter itself, in terms of its charge geometry, the charge is simply the result of the equilateral geometry of the quanta, the squared number of quanta within any equilateral charged fascia or field. We can obviously mathematically determine all of these properties and these relationships, but in Tetrionics we boil it all back down to being mass as a measure of the charge geometries of any EM field, scalar EM field. Of course, the energy of the field by the electric permittivity and the permeability gives us the charge, and it also gives us a measure of mass, with n pi just being reflective of the squared number of quanta within that scalar field. Of course, this picture again shows us various mathematical formulations, all re-expressed in terms of equilateral mass energy geometries. Looking at the permeability of the field, the permittivity of the field, the electric field, which is normally referred to as electric charge, but again the charge itself is the same geometry, positive or negative. What differs is the orientation of the magnetic poles within the dipole field. So the electric charge has no distinct difference. It is just an electric permittivity field of a diamond shape with an associated momenta, or the square root of the equilateral geometry. And again, as the quanta add up within the field, we again of course have a situation where, due to the geometry, an imbalance arises between the positive and negative charges that gives us a net charge. You'll note that when you look at the positive and negative charges in the transverse direction, or the bosons, they always form either a negative or a positive boson, which are normally designated as plus or minus W bosons. And the net field itself is still a charged field of either positive or negative charges. And again, it's a pi geometry, or in the case of EM fields, it would be a 4 pi geometry. 2 pi for the electric, and a pi for the north and a pi for the south of the field. Where we have 2 similar bosons coming together to form a field around a charged particle, the energy momenta of the field will cancel because they're in opposition to each other. So if they're both of equal strength, equal number of squared quanta, they will cancel out and you'll have an electrostatic field But if you look closely at the positive and negative fields in terms of their constituent quanta and charge, you'll see that negative fields have divergent negative quanta with convergent positive energy momenta, and positive fields have divergent positive energy momenta and convergent negative energy momenta. Again, what's really changing is not the electric permittivity or the energy momenta. What is in fact changing is the magnetic moments of the dipoles of these EM fields or quanta. But what's doing the work is not the magnetic fields. What's doing the work is in fact the permittivity or the energy momenta of these quanta and how they affect other charged particles within their field of influence. Of course, this can be drawn classically as a spherical point particle, either positive or negative charges, with divergent charges reflective of the spherical point charge and convergent opposite energy momenta. As I've mentioned a couple times now, it's the permittivity of each EM field quanta that determines whether it's a positive or negative charge. But again, within every equilateral energy geometry, we have the scalar energy, we have the square root energy, linear energy momenta, of course the equilateral quantized angular momentum, and we have a dipole arrangement of a north and a south pole. In the case of negative fields, it's a south-north arrangement as you look at it. In the case of positive charges, it's a north-south arrangement as you look at the field. And again, these are the opposite side of a negative charge is a positive, and the opposite side of a positive is a negative. So as EM fields radiating out into space, they don't present as having any specific charge, but they do have regions of electric permittivity and magnetic permeability within each field of influence for all the energy momenta. And again, as you get closer to a point source, the number of quanta increase, or the bosons increase in energy momenta strength, and this of course means that the field gets stronger as you get closer to the point source, or conversely it weakens as you move away from the point source of the field. Obviously the energy momenta or the electric permittivity of the field affects other charged particles within it, and equally the magnetic dipoles can do the same. In this case, the magnetic dipoles are generated by each particle in motion, as drawn at the bottom of the page, and the magnetic geometries of the fields of interaction of the chem fields themselves between each particle in motion determines the interaction between each particle. Again, this is normally termed as a Lorentz force or Ampere's law for particles in motion. So we can, of course, from this, using single bosons or two boson pairs, form photons of energy where we have two distinct geometries produced by the photons of energy where the two bosons have coupled. In both cases they are static fields where the energy momenta cancels. But in one example we have two similar charges coming together to form electrostatic fields of either positive or negative charges. Or where we have neutral fields, positive and negative charges coming together, we create magnetic dipoles. And again, the orientation of the positive and negative charges determines the orientation of the magnetic moment or the magnetic vector of the magnetostatic field. In these cases, we're obviously referring to the fields being generated by point charges or charged matter geometries. Where we have these same geometries, in these cases a neutral geometry, without a point particle, the fields themselves then don't have a matter geometry to anchor to, so they radiate the energy outwards. And this is, of course, the geometry of photons. So they would then become radiant energy fields without the point particle, but with a point particle, they are in fact magnetic moments or magnetostatic fields. Of course, whether particles are neutral or charged, they are all comprised of charged energy geometries, and they all radiate blackbody radiation. This, of course, gives us magnetostatic and electrostatic fields, as we've just discussed. But within each field, we have differing arrangements of charged Planck quanta. It's these differing arrangements of charged Planck quanta that gives us fields of interaction between charged particles and blackbody radiation. Where they superposition, they obviously affect each other in proportion to the strength of each field between the particles that are interacting. And where they're separate, obviously if a charged particle were to move into this field of influence, the energy momenta within that field will affect the motion of the particle, either draw it towards it or push it away, again dependent on the charge of the particle that's moved into the field. In the case of negative charges, negative particles are pushed away and positives are drawn in, and the opposite is true for positive charges. So in addition to modelling particles and their chem fields when charged particles are in motion using equilateral geometries, Tetrionics can also model the electrostatic fields and the magnetostatic fields of all forms of matter, and the influence of these fields of influence, the effect of these fields of influence on charged particles that move within them. Obviously this forms the basis of Coulomb's law, which is described as the law of interaction within Tetrionics, because the force can be convergent or divergent. It can pull or push dependent on the charge that's moving in the field or being interacted upon. So it's called the force of interaction, whereas historically it's been termed the force of attraction. That term is probably better suited to gravitation, where it's a strictly convergent force. And again, we can use Tetrionic equilateral geometries, where the equilateral geometry itself is alpha, to give us the law of interaction between various charges. Where we have similar charges, two positives or two negatives, the energy momenta push against each other. So they form a force of repulsion. Whereas in the case of opposite charges, the energy momenta act in unison or act with each other to create a attractive force or an attractive force between the similar charges. Again, these can all be mathematically modelled as they were with Gauss's laws example or Poisson, to give us mathematical formulations of this equilateral geometry in terms of the permittivity and the energy density of these fields, which of course they're squared because these fields are superpositioned. So you can see the fields squared, a superposition field in all three cases. The flux of the fields obviously determined by the energy density or the number of energy momenta quanta, equilateral Planck quanta within each field that's superpositioned. And again, we're looking at the electric permittivity. In the case of similar charges, it's repulsive, so a negative force. And we can express all of this again in terms of the Lorentz force as an expression. The force itself is determined by the electric permittivity of the field, by the velocity of the field, because obviously the number of quanta is proportional to the square of the velocity of any particle in motion, E equals mv squared for kinetic EM fields, chem fields. And of course the magnetic field dipoles produce a force as well. So they're all related through the cross products to give us the force of interaction. And again, all of these equations are shown using Tetrionic equilateral geometries of mass and energy. We can of course show the magnetic or electromagnetic field lines of magnets. Of course, where this differs from classical formulations is the fact that we show the E-field permittivities, because again, wherever a field of energy or a scalar field of energy persists, whether it's a charged equilateral geometry or a 2 pi photon geometry, we have electric permittivity as well as magnetic permeability within those fields as a result of the equilateral geometry of energy. Of course, in a magnet, this is not typically drawn, either classically or in current quantum mechanics because of the formulation of relativity. But in Tetrionics we show that even though they are neutralized and not detectable because they are two-dimensional fields made up of positive and negative quanta, and if you count the quanta in both of these fields, they equal. So they cancel each other out as fields of electric permittivity. They are completely neutral. And again, they are two-dimensional, as better shown at the illustration at the top right. So each two-dimensional field has a positive and negative charge. So where we see a positive here in this middle picture, it is in fact viewed from the opposite side, or a Lorentz coordinate transformation, we would see a negative charge because of the arrangement of the dipoles. In other words, to say this, to flip the picture over, you would see a south-north instead of a north-south, or you would see a anti-clockwise vector rotation of the quantized angular momentum as opposed to the clockwise rotation of the same energy as it's modelled. But in all cases, what we're showing here is that magnetostatic fields, or magnets, bar magnets or electromagnetic fields, do in fact have E fields of energy momenta or electric permittivity fields, and they are neutralized. You don't know they're there, but they still, even though they are neutralized, they still contain positive and negative, divergent and convergent energy momenta fields. And these fields can act on charged particles that move through their regions of influence. Again, equilateral geometry as far as the permittivity of the field. And you'll see that the magnetic dipole that exists around a bar magnet is shown here, and it tapers back in the middle to the block wall, as shown here, which is the point of singularity for E and M fields within any 2 pi EM field geometry. In the case of a bar magnet specifically, classically we've had the lines of force drawn as coming in from infinity or going out to infinity with a vector direction internal of south-north internal to the dipole and north to south external. Again, mapping these onto Tetrionic alpha geometries, we can see that to produce a bar magnet geometry of a magnetic field or a magnetostatic field, we need positive and negative charges in order to create the stronger dipole arrangement of the bar magnet itself. But obviously we still retain the E field geometries and their energy momenta, but they're neutralized. And as I pointed out previously, they still retain their distinct positive and negative, divergent and convergent energy momenta. And this is what influences particles, charged particles, as they move through these regions of influence or fields of influence. Again, noting that negative has a divergent negative charge, a positive field has a divergent positive. But for example, an electron placed in this field would be pushed in the same direction because of the north and south fields, and the conventional current flow would be in the opposite direction. So Tetrionics gives us the true electric permittivity and magnetic permeability of the energy fields that make up the energy of bar magnets, as well as the energy of photons. We can use this geometry for all mass energy fields or planar fields, and these were traditionally described by Faraday first off as fields of force, obviously because the energy momenta within these fields, whether it's electric or magnetic, will produce a force on other charged particles or other particles of matter that have charges as they interact with these energy momenta. This is completely different to the relativistic understanding of magnetic fields and electric fields. As a quick side note, obviously in the case of electric and magnetic fields, they do have differing properties. In the case of purely electric and purely magnetic poles, they diminish as inverse squared laws. So as you move out further and further, the strength diminishes in proportion to the square of the distance. But in the case of a magnetic dipole, a north and a south pole, the dipole diminishes at the cube of the distance as opposed to the square. And again, explained in a number of ways mathematically. It's not only formulated the strengths of the field, of the magnetic field, in mathematical terms, but explanations have been created over time mathematically to try and explain why the dipole diminishes as the cube rather than the square, whereas single poles are squares. In fact, Tetrionics reveals what's going on here. A single pole is an equilateral geometry. A dipole has a distinct 2 pi geometry separated. And if you were to, as illustrated here, allow the field to grow over time, 1 second for the central picture, 2 seconds for the picture above, which is each the same energy within the field, but it's over a larger area, and then 3 seconds, and then plot the dipole versus the electric permittivity geometries of these fields as done here, and relate them back to just a linear mapping of those radial strengths. You see in fact that you do get a squared relationship for the electric permittivity and a cubed relationship for the magnetic permeability of the dipole. Of course, a major point that takes a while to understand in Tetrionics is the chirality of charge itself. As I've mentioned, the charge is determined by the arrangement, by the north-south arrangement of magnetic poles within the dipole of the field. And again, there are no magnetic monopoles. They always come as a dipole set or a magnetic moment. So a north-south will always give us a positive charge, which can be modelled as a classical flux of energy about a vector rotation. Again, a negative would be the opposite vector rotation, and it would have a south-north. And this is what's happening in this example, where we have a positive charge and we mirror it either on the horizontal or vertical axes. We see that either in the Tetrionic equilateral geometries or in the classical vector angular momentum, or the system that models this arrangement, dipole arrangement, we see that mirroring or reflecting it in the horizontal and vertical axes results in a change in the geometry of either the magnetic dipole arrangement or the flux, the vector rotation that describes the energy flux that would create such a 0-point field. The reverse direction is obviously reflective of a negative charge, as is the dipole south-north now instead of north-south. So mirroring or reflecting a particle because of its the chirality of the 0 point field, results in a change of charge. Now we can either do it as mirroring or reflecting, or we can in fact describe it mathematically as a Lorentz coordinate transformation, where we change our point of view with respect to either one side of the field or the other, in which case we then obviously again produce the same results that we get geometrically, mathematically. So again, the geometry is giving us the foundation for our mathematics, and it's not the mathematics giving us the foundation for the geometry. The geometry is the foundational basis for all of physics. Again, we can rotate charges of various types, positive or negative, about an axis, whether it's electric or magnetic, makes no difference. But these rotations do not affect the charge. As you can see here, we've done a full 360-degree rotation about a point, and the rotation has not affected the charge of the particle itself, whereas the reflection or the coordinate transformation did change it. And that's the basis of chirality. And again, it's the equilateral geometry of positive and negative charges, or the alpha, the geometry itself, specifically where it relates to the magnetic dipoles, in the case of quantum mechanics and quantum fields, that determines the chirality of the fields and determines the net charge of any mass energies within that field. Again, just to highlight the point here, we can mathematically formulate a lot of things, but geometrically we can describe them a lot easier and more intuitively than we can mathematically within Tetrionics. You can see the geometries of odd-numbered bosons. The only exemption, of course, is the equilateral single quanta of charge, but all the other odd-numbered geometries have this rhombic geometry of parallel and anti-parallel or convergent sides, parallel there, converging or diverging there, depending on which direction again you're looking at. But of course, all these rhombic geometries and equilateral geometries come together to form a net equilateral geometry for the charged fascia, and it's the energy content within these fascia, or energy momentum, that gives us, or per second of measurement, that gives us measurements of mass and of course resultant velocity, all expressed again geometrically, or they all can be mathematically expressed directly from the geometry of Tetrionics. Looking closely at the 0 point fields themselves, or the Planck quanta within any field, obviously we can relate Planck's quanta as mass alpha, and we can in fact express this in terms of force. As we increase or decrease force, accelerate a particle, we have to change the energy content of that field, because we're obviously affecting the force, the energy momenta within the field, to produce a resultant velocity. These are all geometric expressions of Newton's second law, F equals ma, where a force gives a resultant velocity because of the energy momenta in the field, and changes to that momenta are obviously produce equivalent accelerations or changes in velocity. Again, F equals ma, which brings us back to the m, where we describe, as illustrated at the bottom, a positive or a negative charge. Obviously we have a energy momenta system, whether it's linear momentum in the case of the square root, or quantized angular momentum in the case of the geometry of the field itself. Makes no real difference. One is what Newton measured, i.e. the linear momentum. The other one was measured in terms of just scalar energy or kinetic energy, a half mv squared or mv squared. One's a scalar, the other's a linear measurement. But in both cases, the common term obviously is mass, and it acts as the relationship between any velocity or momentum changes within a system resulting from a specific force being applied, F equals ma again. Or looking at the scalar energy, it's E equals mv, mass velocity squared. In the case of kinetic energy, it's a half mv squared, or the electric part of the field, with the magnetic component being a equal strength but a different physical property, magnetic versus electric. And again, they're both half mv squared, so their total energy for the electromagnetic field, or the chem field of the kinetic electromagnetic energies, is of course mv squared. So we can relate the linear momentum to the scalar quantized angular momentum through the square root, or the squaring of the linear momentum. So if we square linear momentum, we can of course calculate for the scalar energy of the field, mv squared. And of course, if you were to take the square root of the energy from mv squared, you get mv, you get of course the linear momentum of the system. So these geometric properties and the equation, the relationship between force and acceleration and velocity and changes in momentum are all shown through Tetrionic geometries of mass energy within fields, be they static fields or kinetic EM fields, which will always be referred to as chem fields. In either case, what the constant here is, or what the relationship between the force and the acceleration, or the change in velocity, momentum, what's relating it all is the mass. And the term mass has been loosely used within physics. It refers to the energy content of a system per unit of time, obviously, but it has been constantly interchanged in current textbooks and historically in textbooks between mass and matter. They are distinct physical properties, mass obviously being two-dimensional energy momenta in a field per unit of time, as drawn here in the central picture, whereas matter is a three-dimensional geometry, charged geometry, created from these energy momenta fields. And that's one of the major distinctions in Tetrionics that will show us where relativity has gone wrong. So, using this definition of matter, we can obviously relate it back to the energy flux in the case of short-circuited ideal quantum inductive circuits, where we have a quantum inductor. We charge it and short-circuit the lead so that the energy flows in one direction or the other through the inductor. This will create a specific dipole arrangement of north-south or south-north. And of course we can look at this as being a 0-point field, or an ideal quantum inductive circuit. The energy doesn't oscillate, it flows in one direction. So where you see terminology of 0-point fields being quantum oscillators, this terminology is incorrect. The only way to get a 0-point field to rapidly oscillate will be to rapidly oscillate your coordinate system, or your point of reference, from one side of the equilateral geometry to the other. Again, remembering that the opposite side of the quantum coin of a negative charge is a positive. So rapidly changing your perspective from one side to the other would create an oscillation. But within the 0-point field itself, from a perspective of measuring, it is a directional flux of energy as it's modelled, or in fact it's the equilateral geometry of the electric and magnetic fields within the equilateral geometry that gives us a positive or a negative charge. If you equate the electric properties to the geometric properties, you can see a quick relationship forming between inertial mass and inductive loop circuits, where the quantum inductive loops will resist changes of energy, as shown above. To increase, or to apply a force to increase the velocity, you obviously have to change the number of energy momenta within the field, which is what's happening on the right hand side. We've increased from a velocity of 6 to a velocity of 8, so we had to add 2 bosons. Again, specific number of quanta, and odd quanta at that, add up to 28, but it's a dual boson addition of 13 and 15 specific energies to create the final velocity of 8, which is of course the result of the square root of 8 squared. So we change the velocity or the momentum of a system not by changing its mass, but by changing the mass energy or the energy momenta of each charged mass energy geometry. Of course, energy per second is a measurement of mass, but in this case what we're physically changing is the number of quanta per unit of time. In reality, both of these fields would be identical sizes, that they just weren't because of space. And then you would see a relationship between wavelength and frequency as well. But it was done this way to highlight the fact that we add 2 bosons of energy, or energy momenta, to the field to give us our resultant change in velocity or acceleration, or our change in linear momentum in the system. But in both cases, however it's measured, we can relate it all back to inertial mass, i.e. the physical system itself will resist changes to its velocity due to force. There will be a inertial resistance to any changes in velocity or momentum in the system. And this, of course, is Newton's laws of force, F equals ma, etc. And the geometry of these energy momenta, the equilateral geometries within any measurement of time, these, of course, are energy fields. If they were mass, they'd have a specific time geometry, which would then fix the geometry of the mass energy. They have a specific geometry, and it's that geometry that gives the inertial properties, as each quanta is a quantized inductive loop of energy. So this is the electromagnetic basis for inertial mass within all of physics. As we add quanta to each charged fascia, or each EM field, we increase the mass energy of that field. And of course this gives us properties of mass. The energy momenta will give us properties of force for both fields of interaction as well as solidity to matter, and inertial properties of mass for matter as well. We increase the energy quanta in each charged fascia, we increase the mass and its inertial resistance to changes of energy in the system. And that's what's described here. We have 2-dimensional equilateral chem fields, or fields of electromagnetic energy. These can obviously be the result of the motion of a particle through space. It's kinetic energies, electric and magnetic, or the kinetic energy and the magnetic moment of the particle in motion. Or it can be the energy momenta, or the mass, that makes up the standing wave of matter itself. Again, being very careful to distinguish and be clear that we're talking about mass within matter and energy mass within chem fields. The distinct terminology is extremely important in understanding how Tetrionics relates to and disproves special relativity. Of course, throughout Tetrionics you'll see n pi for mass energies and t pi for matter geometries. Of course, the T standing for tetrions, which are 4 n pi geometries of standing waves, as illustrated here. This page gives a clear representation of the physical relationships resulting from the equilateral geometry. What we have here on the left-hand side is mass, as defined in Tetrionics. It's the result of energy, which is the Planck quanta down the bottom, per unit of time, per radial unit of time, c squared. So E divided by c squared gives us mass. Of course, it has the properties of electric permittivity and magnetic permeability, as we've discussed, and the relationships between the force it can exert, or the velocity it can create, is directly related to the square of the energy momentum quanta within that field. So we have energy momenta, square number of energy momenta, making up a scalar mass field, because it was the energy momenta was measured per unit of time. And this is our definition of mass. Again, as you can see here in the Tetrionic formulation, it's just n pi energy per c squared. If you didn't have the radial measurement of c squared around this, it would just be n pi energy, and be a measure of the energy, with the square root being the linear momentum, and the geometry being the quantized angular momentum or charge. And that's what's drawn in the middle, the energy geometry. Obviously lacking the radial time measurement of any sort, whether it's c squared or c to the fourth or c cubed, there is no radial measurement. There is a linear vector measurement of c, or velocity, and that total energy linear energy momenta is related to the square root of the quanta that makes up the field. Again, in the case of two-dimensional mass energies, as non-matter geometries, as radiant EM fields, that they are neutral fields. That there's not a specific charge one way or the other until you measure one face or the other. Then you can determine a charge for that face and infer the charge for the opposite face. But as a freely moving or propagating wave, they tend to be described as neutral, because they have a positive charge on one side and a negative on the other within any region of measurement. Where this changes is obviously where you form tetrahedral geometries, and obviously only one side of the mass energy geometry will be expressed, the other side being buried inside the geometry of, well, the standing wave geometry of matter itself. So in which case the neutral property, or the neutral detected properties of radiant EM waves, mass energies, becomes a charged matter geometry with a net charge reflective of its charge geometries. And this can be either positive net charges or negative net charges, or a neutral charge. Again, even neutral matter is made up of positive and negative charged fascia. And these are all equilateral mass energy momenta. Again, Tetrionics defines them as T pi geometries of energy per c to the fourth spatial geometry. And this n pi versus t pi, as well as the c squared versus c to the fourth, is usually the quickest way to distinguish between whether you're defining mathematically mass or matter. Obviously the energy remains the same all the way through. We're just changing the form, or the charge geometries of the energy in all cases. And the linear momentum is obviously just a square root of the energy. So the unified Tetrionic field equation now easily defines mass, energy and matter in terms of its energy momenta and its geometry. As we mentioned earlier, Tetrionics departs radically from current and previous formulations of quantum mechanics and physical mechanics at the quantum level, atoms, in that it has equilateral mass energies and tetrahedral matter quanta, tetrions. Obviously in the previous formulations and mathematically these are expressed as 4 pi spheres. Mathematically they're identical, they are both 4 pi. There is, however, a charge, obviously, in a change in the geometry due to the charge. In the case of a sphere, it's spread out, and many creative solutions have come about trying to explain where magnetic moments come from and things like spin. Tetrionics reveals all of these properties to be the result of equilateral energy momenta. Again, the mathematical formulations remain the same for triangles and spheres within Tetrionics. What changes is our understanding of the quantum geometry of Planck's constant itself and energy momenta in general. Obviously, in terms of mass energy matter, we have energy or mass energy fields, two-dimensional planar Euclidean energy geometries. Again, n pi, any number of energy momenta fields can come together to form different charged geometries. These ones illustrated here are the bosons, or 0-point field specifically, and the bosons, W and W plus, W minus bosons. These, of course, come together to form equilateral mass energy fascia in the standing wave geometries of tetrions. Obviously, tetrions and quarks and leptons all form fermion or fermionic matter. Tetrionics calls them tetrionic matter because of the tetrions being the quanta of their matter geometries. But in all cases, the more or less neutralized charges, or charges that were neutralized within EM fields of mass energy, become specific net charged geometries for each and every particle within the universe. Every form of matter is a result of these tetrions coming together and interacting via the strong force. As we increase the energy on each charged surface in matter as it's created, we obviously increase its energy momentum content and its geometry. Well, the geometry remains the same. It's the quantized angular momentum, the alpha, is equilateral, but what does change is the linear momenta of the system. There's a relationship between the frequency, or the number of quanta, and the wavelength that's produced as we squeeze more and more energy momenta into these charged fascia. Obviously, the charged fascia does not change its physical dimensions. What changes is the wavelength of the energy momenta quanta within these geometries, because we're cramming more and more in. So as we increase the frequency, we decrease their wavelength. And the relationship between frequency and wavelength is velocity. In this case, it's the natural velocity of energy momenta, which is the speed of light in a vacuum. So matter itself is shown to be comprised of mass energies, all propagating at the natural speed of energy, or natural velocity of energy, which is also known as the speed of light. And this is what gives matter its three-dimensional solid form that we're aware of in the macroscopic world. You can think of it as perhaps like a denim fabric. As you increase the number of fibers, or the number of quanta, to the material, the canvas that's wrapping around this structure, it's equivalent to the mass increasing. It's becoming more and more solid. You can start off with tissue paper and build your way up into, say, canvas for each energy level. All we're doing is increasing the energy momenta within each charged equilateral fascia. This gives us our geometry of matter. And the same geometry applies to the kinetic EM fields that are produced by matter in motion. As a force is applied to any standing wave of energy, any matter quantum, and accelerates it or increases its linear momentum, obviously the energy must be increased or inputted and stored somewhere. It's not stored in the matter geometry, which is already propagating at the speed of light. It is in fact stored in a externalized chem field, indicated as kinetic EM, a field that has kinetic electric or kinetic energies and a magnetic moment, an electromagnetic field. And of course the formulation for any EM field is mv squared. Of course, with particular attention paid here to the fact that it's a kinetic energy field, from matter in motion. So it's a capital M for mv squared as opposed to lowercase mv squared for mass energies. This is where we have to start taking more and more care as we explain things, particularly in terms of mass energies and matter geometries, and how they relate to relativity. In the case of relativity, charged particles, or leptons specifically, in motion, have a relativistic mass energy, as indicated here in the red. This is the result of all their mass energies, or their matter, plus their kinetic energies of motion being combined. We can draw this with equilateral geometries, simply just as a charged particle with its chem field around it. And again, the chem field dipole arrangement, or the magnetic moment, is always reflective of the net quantum charge of the particle itself that's in motion. So in this case we have an electron with a negative charge of negative 12, or a negative elementary charge. That's being accelerated, and as it accelerates, the energy from the force accelerating it will be stored as mass energy momenta within its chem field. The mass energy of the charged fascia of matter does not change with velocity. It is Lorentz invariant. And we'll show this in a number of ways as we work through the undermining and redeveloping special relativity and the understanding of quantum mechanics and electrodynamics. But as we've said, all the energy momenta from the force or the acceleration of the particle is stored in the chem field, as illustrated here, and it gives a resultant velocity, which is directly related to the square number, or the square root of the square number of energy momenta that the force supplied. Of course, if you slow the particle down, it will release this energy in order to slow down. Any particle in motion tends to remain in motion unless acted upon by a second force. We can represent this with the illustrations that you see here for leptons or electrons. They're negative charged energy matter geometries, all standing waves made up of tetrions. 3 tetrions in this case, giving us a 12 pi negative charged geometry. So you'll see here that the mass energy of the matter geometries, 12n in all cases, does not change as we increase the energy, the relativistic energy of the particles themselves. So as we go from N1 to N8 energy levels of the electron, whether it's bound or not bound, makes no difference. The energy is stored within the chem fields of the particle that's being accelerated. And it's the invariant mass energies of the matter plus the variant mass energies of the chem fields that give us the relativistic mass energies, or the total mass energy of the particle in motion. Again, importantly noting that in Tetrionics we have a charged geometry for all matters versus a spherical geometry for matter in relativity and within classical mechanics, quantum mechanics and QED. Looking at these fields from another direction, i.e. a polar view of the electrons, again we see that there's a little error on this page that should be reversed. We see that the mass matter does not change. We hear me refer to it mass energy of matter. You'll hear me call it mass matter. It implies that the energy is there. So the mass matter of the standing wave geometry does not change as we accelerate the particle from 1 through to a velocity of 8, or in the opposite direction from 8 through to 1. There is no change to the mass matter of the electron. What does change, as illustrated here, is the mass energy of the chem fields that result from the motion, from the particle in motion. In this case we have a negative particle, an electron, so we have a south-north chem field or magnetic moment of the chem field. Of course, the energy that's in the magnetic moment is equal to the kinetic energy, a half mv squared for both of them, giving us a total energy of the chem field as mv squared, as shown here. The kinetic energies are equivalent to the electric fields. They're measured not as electric fields because there is a positive and a negative side to the chem fields. They're planar mass energy fields. You can think of them as a sheet of paper extending out from the electron, an equilateral geometry that points out, and that geometry expands because it's not fixed. It expands out dependent on the mass energies within it, creating a field of influence between the electron and any particle that comes within its sphere of influence, or the field of influence. Again, note that we list matter with a capital M, whereas the mass energies of either the chem field or the matter itself is listed as a small m for mass. The linear momentum of any particle in motion is its matter, or mass matter, velocity squared. We do it this way because obviously it's the particle itself that's being accelerated and its mass energy within that charge matter geometry. And that's what we're calculating for. We need a specific energy within this chem field to accelerate the entire system to a specific velocity. And again, the velocity that's achieved is proportional or related to the square of the energy momenta required. And again, it's related to the amount of mass matter within the particle. Heavier particles require more quanta to accelerate them to the same velocity. Now with Tetrionics we can clearly show, I won't go into great detail on this illustration, but we can clearly show that all mass matter geometries have constituent energy quanta within them, and they all have specific charge geometries, irrespective of what their net charge is or their physical properties. It's the equilateral charge geometries of all matter that gives them their distinct properties. And we can show this a number of ways, as done in Tetrionics, as to the application of these mass energy matter geometries. Again, we can show clearly in Tetrionics that the electromagnetic mass energies and charge geometries of matter itself are in fact electrical equivalents, and we can exploit these electrical equivalents to both understand how matter itself works at the quantum level, as well as exploiting macro scale examples of these quantum processes to give us more energy, or more efficient energy sources and energy storage. As I mentioned a couple of times, the equilateral geometry obviously dictates the mathematics that can be developed to describe physical systems. And this page here just gives us the relationship between kinetic energy of chem fields versus the momentum that the chem field can create, or the linear momentum. The kinetic energy obviously is half of the energy of the chem field itself, the other half being the magnetic moment of a particle in motion, a charged particle in motion. Obviously the linear momentum that can be produced is the square root of the energy in the chem field, or the result of the divergent and convergent energy momenta within the chem field itself. Again, the convergent and divergent energy momenta not only give us a net linear momentum based on the square root of their squared quantum numbers, but they can also give us the interactive fields of force between charged particles, which of course is the familiar laws of interaction. Of course, as we've mentioned, the energy itself is mv squared in the case of the field itself, or in the case where we're referring to it as matter in motion, a chem field, it'll be matter velocity squared. But in both cases, the square root of the energy field gives us the linear momentum, or squaring the linear momentum of the system will give us the energy, the scalar energy. And we've illustrated all that with the equilateral geometry in the center there. In the terms of mass, energy, momenta, as we mentioned, the right-angle geometries of relativity and relativistic textbooks is incorrect. It's equilateral geometries now. And again, we can generate all the familiar laws of force and energy, momenta, mass, and the permittivity and the permeability of the fields themselves can all be generated from the equilateral geometry of energy momenta. In this case, you can see at the right hand side the Lorentz factor, and this simply shows the relationship between the relationship that comes as we increase the velocity of a particle. As we increase the particle by obviously applying a force to that particle, more energy momenta is stored in the chem field geometry. As the energy momenta increases, the wavelength of those energy momenta, the linear wavelength, decreases. Again, you'll see this mentioned in textbooks in a number of places, just as wavelength contraction, especially within relativity. The mathematics of Lorentz's formulations, as well as Einstein's formulations, could not express the difference between mass, energy, and matter, except in mathematical formulations. Tetrionics gives us the clear understanding of mass, energy, and matter in terms of two-dimensional chem fields, as well as standing wave matter geometries. And as matter is invariant, all the energy is stored within the chem field. Accordingly, as we put more and more energy into this fixed chem field geometry, because it's a per unit of time measurement, it's a mass energy measurement, we obviously must decrease the wavelength, the physical wavelengths of the quanta themselves in order to fit into this fixed charge geometry of the chem field. This then shows us not only where the energy is stored and the difference between mass and matter within Tetrionics, it also shows us that the Lorentz correction factor only applies to mass energy within chem fields of particles in motion. The mass matter of the charged particle itself is already a standing wave propagating at c. It is Lorentz invariant. It's not affected. No energy is added via the force to the charged mass matter geometry. The force instead adds its energy momenta to the chem field geometry. This creates obviously kinetic energy of motion, as illustrated. It creates a linear momentum, the square root of the field, and it also creates a magnetic moment from the addition of energy quanta. But in all cases, what is changing is the wavelength of the energy momenta in the chem field in relation to the frequency or the squared quanta within that field. And I keep stressing wavelength for a particular reason, and that is because you will see it listed in books as a length contraction of the matter, i.e. you'll see things like the train shrinks slightly as you accelerate it towards the speed of light. The electrons become squatter, they distort as their velocities increase within the hadron collider. None of this occurs. What changes is the wavelength of the energy momenta within the chem field. Of course, this is a measured by the linear momentum as indicated with the fuchsia arrows here. The length of these linear momenta becomes shorter as we increase the number of quanta within the field. I know I've laboured on it, but it's extremely important that you understand that the energy of any force applied to a particle in motion stores the energy as mass energy within the chem field. The matter itself is Lorentz invariant. And this completely flies in face of the pictures at the top right hand corner where right angled triangles are used and applied to the mathematics. And from that they derive the fact that the energy, mass energy, the total mass energy of the system increases, so therefore the length of the mass, the matter and the energy changes. And this is not what is happening. In order to understand quantum mechanics and its application to all scales throughout the universe, you have to have a clear definition of mass, energy and matter. From that you can understand the mechanics, the physics of motion, and then understand what's really going on. And that's what we're showing here. Obviously the relationship between the velocity that the energy momenta within a chem field can create can be measured as an efficiency against the natural speed of light that a single energy momentum can create. Again, electric fields by magnetic fields give us a cross product of the natural velocity of light, of energy, which is the speed of light. So the relationship between a particle being accelerated and its velocity compared to the scalar energy momenta that creates that velocity or momentum, linear momentum, can be expressed in terms of the velocity created against the natural velocity of the part of energy. In the case of linear measurements of momentum, for example, or wavelength, these are V on C. In the case of a scalar measurement, obviously we're measuring V squared versus C squared, or compared to C squared, the square of the linear. Again, you can see the relationships between linear as square roots and scalar energies, or mass energies, within the same field. They're all expressed with beta, or Lorentz velocity correction factors. And again, mathematics classically draws this as a curve rising up, when in fact equilateral geometry shows us that there is no limit to the velocity that's obtainable. In fact, if you go past c squared on c squared for the quanta, you will in fact produce a linear motion that is in excess of c, or a superluminal velocity as indicated here. Again, what Tetrionic geometry is showing us here is not only the mass, energy, matter, momentum relationships for the chem fields and the velocity that they can produce in relation to the force applied, but it also shows us where mathematics has erred in its application, or how it's strived to understand what is being described at the geometric level. Without the geometry, an assumption has been drawn that C is the limit, when in fact no limit exists. As I keep mentioning, the speed of light is commonly referred to in Tetrionics as the natural speed or natural velocity of energy, because there's a relationship between wavelength and frequency within chem fields, or within any EM field, whether it's a charged, radiant charge field, or whether it's a photon. Makes no difference between all three forms of mass energy fields. The wavelength frequency relationship is determined by the geometry, not by the mathematics. It just happens that the mathematics reflects this geometry. But again, the geometry is the foundational is foundational to physics, whereas mathematics simply is our attempt to describe this geometry without knowing it. You can obviously measure the strength of the electric permittivity and the magnetic permeability, as Maxwell did. It will give you a number for the scalar EM field, and if you want to know the velocity that energy momenta of the E and the electric and the magnetic fields can create, you simply take the square root of the scalar field. And whatever the frequency wavelength relationship is, it will always be a velocity. Again, it will be determined by the particle being accelerated versus the energy momenta within the field, and again within the medium that the particle is moving. So we express it as a velocity, not c, as it's commonly shown. But irrespective, in the case of our EM field, the frequency wavelength relationship is a velocity, and in the case of a purely electromagnetic field that's propagating freely in space or in a vacuum, we will get the speed of light. And this was Maxwell's clue that light was in fact an electromagnetic wave. But again, errors stem from the mathematical formulation that the geometry will correct. So we can clearly show, as we do in chemistry and other previous lectures, that the mass energy content of any charged field forms the charge geometry or the fascia of all standing wave matter, and that this geometry is invariant to changes in velocity. What we can do is obviously change the amount of energy quanta within the field to increase its mass. Obviously we can measure this as a change in quantum level energy, as we do in the case of radiocarbon dating, where the mass energy of the charged geometries themselves is increased from one quantum level to the other. In doing so, we can calculate for the mass energy, or the mass matter, of each matter geometry, or each element in this case. And there are other examples where mathematics was proven wrong, in this case specifically with the fact that irrespective of its isotope number, carbon-12 always has only equal numbers of protons, electrons and neutrons, or 6 deuterium nuclei that make up the carbon-12. What changes is the mass energy content of those charged fascia. And that's shown on this page here, where in the case of rest charges, or particles that have no blackbody radiation or energy of motion, we can calculate an exact rest mass energy for the matter geometries. You can see here in the case of electrons, we have a Tetrionic mass matter of 12 charged geometries, giving us a mass matter of 1.2 by 10 to the 20 Planck quanta. We can then convert this from one form to the other, mass to energy or to electron volts, however we choose to measure it, and we get exact values for the mass, the energy of all matter geometries. Any additional blackbody radiation or raised kinetic energies, raised quantum levels, along with the energy of motion, is stored as mass energy in two-dimensional fields. You will note here that protons and neutrons, because of their charged geometry, are identical in geometry. They are also identical in mass matter, 930 mega electron volts in both cases. You will see a lot of textbooks again saying that neutrons are slightly heavier. This is not the case. So again, just refreshing, the mass energies of the charged geometries, or the charged fascia, give us the mass matter of each particle. They obviously, the charge, the net charge that results from the differing charged geometries that make up the particle, give us our net charge on the particle. In the case of electrons, it's a negative 12. Protons with 36 charge fascia compared to the 12 of the electron have a positive 12 charge because of the makeup of positive and negative charges within their geometries. And neutrons have a neutral charge resulting from the 36 charge fascia. These particles then obviously come together because of the difference in their charge geometries. And the second law of Tetrionics states that all energy will seek equilibrium, whether it's an energy density equilibrium or whether it's a charge equilibrium makes no difference. They will seek to form a stable low energy state. In doing so, they bind together to form hydrogen, for example. In this case, we've calculated for the exact rest mass matter of hydrogen without any blackbody radiation and without any kinetic energy of motion. Where we have charged geometries of matter, obviously they interact with external EM fields in their environment. And as these charged angular fascia of matter move through the external fields will seek to add energy to their charged fascia because, again, remembering each charged fascia is an equilateral geometry which can be likened to a quantum inductive circuit. As the inductive loops of each fascia move through the external EM fields, as drawn here, it's the charged angular fascias of matter that interact more greatly, or to a greater extent, than planar 2D mass energies do, or radiant energy fields. Bosons and photons have no real interaction with external fields. They do interact, and they can do via their magnetic moments, for example, but compared to matter itself, it's almost a negligible cross-section as far as interaction. Matter will always interact on an inertial level at a much higher rate than radiant EM waves. We of course describe the EMs as non-Tetrionic geometries. That is, that they have no three-dimensional component. They're all two-dimensional. And again, this is the major distinction between two-dimensional radiant EM fields, bosons and photons, versus 3D Tetrionic matter or fermionic matter, where we have faceted angular geometries. So the mass energy of each charged fascia contributes as inertial mass in the case of three-dimensional matter particles in motion. Again, the mass energy is the inertial mass of the matter. It's a standing wave geometry, so it is invariant to Lorentz to velocity changes or Lorentz correction factors. All the energy of force that is applied to a particle to accelerate it is stored within the chem field geometry. And as matter is accelerated from a standing point, a rest point, the mass energy momenta within the chem field to have a specific orientation of kinetic energy, neutral kinetic energy, and a magnetic moment resulting from the north-south or south-north arrangement of the magnetic dipole of the field itself. The particle itself, as I mentioned, is Lorentz invariant, so it does not squash, it does not change geometries. It is a charged mass matter geometry that is Lorentz invariant. All the energy is stored in the chem field. Where you see relativistic energies, as indicated here, you know that it is the rest mass matter or mass energy matter plus the mass energies of the chem field. And these chem fields are affected by velocity changes or are Lorentz variant. as we add more forces to a particle to accelerate it, more quanta or energy momenta, mass energy momenta, is stored within the same chem field geometry. And it is the wavelength of this mass energy that changes, not the mass of the matter. Again, the chem field's energy, scalar's energy momenta, is determined by matter velocity squared. There exists a relationship between mass and matter that we've discussed within Tetrionics, and that is namely that mass is the measurement of energy per c squared, a planar Euclidean field, radiant, whereas matter is a three-dimensional standing wave of mass energies, and that's measured in a spherical geometry or coordinate system of c to the fourth to accommodate negative z components as well as positive z, and so as to remove the Cartesian geometry from relativity. Of course, looking at these two equations, you can see that there is a relationship between mass and matter, and that in terms of energy they are completely distinct properties or distinct values compared to each other. Mass is not matter and matter is not mass, but in both cases they can contain equivalent energies. Energy is the common form, as in equilateral energy geometry, square root being the momenta, energy momenta, quanta. Matter being the equilateral mass energy, equilateral energy momenta per second, per c squared. Matter being mass energy matter per c squared. There is a relationship between mass and matter of c squared, and we'll discuss this further on. So we can clearly define mass, energy, and matter along with the angular or quantized angular and linear momentum properties of any system. And we can clearly define between mass and matter. In fact, this is crucial to understanding where relativity went wrong, both in its mathematics and in its foundational assumptions about what was causing various physical properties. Again, we have the relationship between two-dimensional mass energy, and that is different to the relationship between matter energy, and the difference being the coordinate systems that's employed between two-dimensional and three-dimensional coordinate systems. The mass energy of any matter geometry forms a standing wave of a tetrahedral geometry, and then these tetrahedral geometry interact via their charged fascia to form larger scale fermionic matter or Tetrionic geometries. They all have the same mass energy momenta relationship, and that's obviously related through the geometry of Tetrionics, or the equilateral geometry of energy momenta itself, where square energy momenta quanta produce a specific velocity due to their net force that the momenta can produce, and when measured per unit of time will give us a mass measurement of equivalence to the energy momenta. And these can all be expressed as Planck quanta squared equals the energy, scalar energy, which equals mv squared. So through the Tetrionic geometry for mass energy momenta, we can in fact give an equivalence between classical mechanics and quantum mechanics. Of course, you rarely see Planck quanta squared in the current textbooks, and this is because they never had the geometry to do it. They simply said Planck quanta is just the total quanta of the system, and then erroneously said that that equaled the frequency. Again, bosons do not equal photons. Just so that we're clear, we'll have a recap on the inertial resistance to force. As we mentioned, E equals mv squared, which equals hf. It's also the square of the linear momentum of the system, as far as equilateral mass energies go. And it's the wavelength that changes as we change the force, as the applied force is changed, or the energy momentum, quanta, changes. The geometry of the field stays the same. It's a mass geometry. So therefore, as the force is applied, the energy momenta produces a different resulting velocity, or a change in linear momentum. Again, change in velocity is acceleration. Momentum is just change of mass-velocity relationships with respect to time. So we have all the classical formulations of Newton's laws now expressed in a quantum mechanical basis, or in fact a Tetrionic basis, where we show the relationship between mass, energy and matter. And of course, in the case of 2D fields, it's referring specifically to the mass energy of the chem field for the particle in motion, and the inertial mass predominantly refers to the charged mass energies of the matter geometry. It's an angular geometry, so it's the energy content of the standing wave mass matter, or energy matter, that gives us values for inertial mass when compared to changes in particle momentum, etc. Adding the mass energies of chem fields to the standing mass matter geometries, or mass energy content of matter geometries, gives us the total relativistic mass energy of the system, or the particle in motion. But again, the wavelength contractions or corrections only apply to the mass energy contents of the chem field. And this is what we show here. On the left hand side, we have the relativistic view of a spherical point charge compared to the 12 pi Tetrionic geometry of matter for leptons. The relativistic geometry just shows us a spherical point charge of -1 elementary charge. Tetrionic geometry shows us the net charge to be -12 as a result of the 12 negative charged mass energy fascia that make up the geometry. It also shows us the unique angular geometry of three-dimensional leptons, along with the fact that they are in fact quantum electrical rotors that work within the deuterium nuclei to produce energy and release it. It also allows us to see the exact arrangement of dipoles within the charged fascia. And this of course shows us that in the case of static particles or rest matter, that the magnetic moments are in fact neutralized. So you would not detect a magnetic moment, because any south pole brought in to detect a north pole would not only be attracted by the north, but would be repelled by the south. So you would not be able to detect it. But then again, the dipole arrangement that does physically exist, even though it's not detectable on a macro scale, does produce negative charge geometries. And the mass energy content of each charge fascia gives us a rest matter property for leptons, or in this case electrons. We can obviously use this to calculate the de Broglie wavelength of the matter itself, along with the mass of the lepton or the electron when there is no blackbody radiation or kinetic energy of motion. These are all, of course, c⁴ measurements, because they're spherical coordinate systems used to measure the three-dimensional matter. Of course, as we add kinetic energies or apply force to the particle, it will begin to accelerate. And it does this because the energy of the force, the energy momentum that the force applies, is stored in the chem field geometry, which has a kinetic energy and a magnetic moment, again kinetic energies of motion. It is a 4 pi field because there's 2 pi of kinetic energy and 2 single north and south pole magnetic geometries for the 2 pi magnetic monopole that's created, magnetic moment I should say, that's created. So a 4 pi mass energy geometry. And of course the relationship between the velocity that's produced for the amount of energy momenta in that field is related through the square of the velocity, and it can be expressed in terms of the scalar Lorentz factor or correction. So we can see again how the wavelength will decrease as frequency increases. And of course in the case of the chem field, it'll be our c squared coordinate system we use to measure it. So we have c squared for mass energy, c to the 4th for matter geometries. Combining the two, the force stores its energy as kinetic and magnetic moment in any chem field of matter. The matter itself is Lorentz invariant. You can see that here that it still has the same charge. Charge is conservative. Mass energy matter is Lorentz invariant, with mass energy being conservative, matter not being conservative. And to calculate the relativistic energies of the system, we simply add the kinetic energies to the rest mass matter or mass energy matter. Of course we can draw it as a simplified Tetrionic geometry of the same system as well. But in this case we add the 12 pi matter geometries to the chem wave mass energies, and this gives us the relativistic energies. Again noting that it's the chem wave mass energies that are Lorentz, that have Lorentz corrections applied to them, not the matter. This applies to all electrons within nuclei. It applies to all electrons that are unbound from nuclei, as illustrated here. But in all cases they can be represented as shown with the diagram, and they follow the geometric the geometry for mass energy momenta, which gives us the mathematical formulation of matter velocity squared equals kinetic energies equals Planck frequencies or Planck quanta. Again, being careful for the correct units. The difference isn't expressed in mathematics, but it's very clear the difference between bosons and photons in Tetrionic geometry themselves. Of course, if we're measuring mass, the chem field energies have identical geometries. They're all measured per c squared, so the charged geometry, the equilateral geometry of the chem field itself does not change. What changes is the energy density of mass energy within that field, and that's what's indicated on this page. As we increase the velocity from 1 through to 8, or the energy level of the electron from n1 to n8, it's all proportional to the square numbers. The square number of quanta within each field increases because we're adding bosons, as indicated in the picture above for the ball radius schema. So each color represents an increasing or a changing energy density or mass energy density. Because the chem fields are identical geometries, it's obviously reflective of mass energy. And in all cases, the electron mass matter geometry remains invariant. The changing wavelength, because of the changing number of quanta in the chem field, obviously can be re-expressed instead of as wavelength as a wave number. Instead of the length of the height of the equilateral triangle or the chem field, instead of wavelength measuring the height or the length, we can in fact measure how many quanta per meter, or how many quanta per linear meter, and this in fact is a measurement of wave number. It's a spatial measurement or the inverse measurement of wavelength. This is the formulation, of course, for Rydberg's spectral lines, with Rydberg's constant there, and wave number being calculated for. Again, the Tetrionic geometry shows us what is physically happening here, whereas historically the math, although it worked, was never explained or properly explained as to what was creating the specific mathematical relationship. So in the case of charges or charged matter in motion, irrespective of whether it's an electron as illustrated here or any other charged particle or any particle made up of charged geometries, Tetrionics will explain a number of things that still remain, even with relativity, to be mysterious. The first one obviously is the basis of relativity itself, and this is that changes in the velocity of a charged particle produce an associated magnetic moment. We've shown that this magnetic moment is simply the half of the kinetic or the chem field energies, and it has a specific dipole arrangement determined by the charge of the point particle that's being accelerated. So whereas Einstein's model of special relativity says that the spherical point charge of an electron is distorted, as shown here, or squashed into an oblong shape, and this distortion becomes greater as the velocity increases, Tetrionics in fact shows us that this is not the case. The matter remains a 12 pi Tetrionic geometry, and we can model it using Tetrionic geometries and show the chem field arrangement, which will give us the magnetic moment of the charged particle in motion. Of course, as the velocity increases, so does the square of the quanta, or the squared quantum numbers, and this gives us a decreased wavelength for the increased frequency of quanta, and it gives us a specific dipole or magnetic moment arrangement that reflects the net charge of the particle concerned. It's the chem field that gives us the magnetic moment, not any distortion in physical charge geometry. And again, it's the chem field that we can apply to a lot of the physical laws and to quantum processes and explain things like Ampere's law and the forces of interaction between particles in motion. Historically, these have all been calculated for, measured, and mathematically formulated to give the results, but in all the cases, the exact physical geometries and processes at work have never been explained. Again, the mathematics is simply our attempt to describe the physical processes at work with respect to the various physical properties of each system being measured. And again, noting here, length contraction is in fact wavelength contraction of the energy momenta within the chem field. Of course, in the case of electrons, and that's important to note here, as highlighted in the middle of the page, the electron itself is a 12 pi geometry, a lepton geometry where the three tetrions are held apart in a unique three-pole rotor geometry by the repulsive strong force between their charged fascia. So between these separated charge fascia of the electron, we have negative charge fascia, and they repel. And that keeps it in this geometry. Where we have positive charges here, they would of course attract, and it would create up and down quarks, etc. instead of lepton geometry. So we would have a quark geometry. It is the strong repulsive strong force between the charged fascia that gives us the unique geometry of leptons. And as three-pole rotors, they are unique in that they do have a physical spin, and their mass-charge ratios generate a higher, a stronger magnetic moment in relation to any velocity than a larger mass would. So we have a negative elementary charge And because it's a lighter mass-matter geometry and a very efficient three-pole rotor geometry, we in fact create a much stronger magnetic moment from its motion in external EM fields than, say, the positive, identical but positive charge of the proton, which has a higher mass-matter geometry, therefore the same amount of energy momenta in the chem field, because of the increased inertial mass, will not produce as strong a magnetic moment as the electron does. So again, this shows that the electron has a real physical spin, has a real non-point, non-spherical geometry, and this geometry is very efficient at creating a strong magnetic moment for any application of force to the particle itself. Of course, the electrons produce Bohr magnetons, and the protons produce nuclear magnetons, or particularly in the case of elements themselves. As we just discussed, the Bohr magneton for electrons is much stronger than the nuclear magneton produced by protons and deuterium nuclei in elements. But in all cases, we can model them with Tetrionic geometries. And by modelling the magnetic moments, both the nuclear and the Bohr magnetons, we can determine the parallel and anti-parallel arrangements of magnetons within atomic nuclei or elements. And this will give us the differing energies in fine line splitting, etc., or within spectral lines themselves. This highlights obviously that where we accelerate particles to high velocities and then slam them together in colliders to determine their constituent particles, we have a number of problems being raised. The first one obviously is the fact that we don't distinguish between mass, energy and matter, and particularly so where we've had a collision where a lot of it is obviously in the form of energy, and it is only the time measurement that gives us a measurement of equivalent measurement of mass, but it does nothing to determine what the matter geometries are. We can only determine this by measuring the mass charge ratios of particles within the collisions by using detectors. Obviously, they're still related to each other. The mass is related to the energy and the matter through E equals mc squared, Einstein's formula of equivalence for mass energy. Matter, obviously having a different coordinate system, is still related through c squared, and obviously this is just a velocity relationship. So as we increase the velocity, we increase the mass energy content of the chem fields of each particle. These of course contribute, along with the mass energy of the matter, to the total relativistic energy, and when it collides, the matter components are destroyed. What is released is mass energy, depending on the system of measurement. It's all quantized, as in they all have equilateral geometries, and the number of quanta equals the velocity of collisions and the mass energies of the matter geometries that are collapsed. Again, matter is not conservative. So where matter is destroyed, there is no need to have other matter geometries created on the other side of the collision to balance out the equation. You can in fact convert all the mass matter into mass energy, or in radiant energy, and this is what normally happens within the collisions. Some of the mass energy does in fact turn back into matter geometries, and all of these interactions between mass, energy, matter, the charge geometries, and the energy of motion all contribute to making investigation of quantum mechanics through accelerator collisions a extremely difficult process. In fact, Tetrionics now shows us through the equilateral geometry of mass, energy and matter all the things that the Large Hadron Collider and accelerators prior to that have been trying to achieve for at least the last 50 years. We've done all this on paper with a simple high school calculator. By knowing the geometry underlying the math that the mathematics describes, we can not only calculate and determine a lot of the physical processes and properties at work at the quantum level, obviously processes and properties that we will never see with the naked eye or within particle detectors, but we can also see whether mathematics has erred or has been unable to correctly extrapolate what is going on. And now we can also show where particle collisions only serve to increase the level of confusion. Obviously, the main difference here at the quantum level is the distinction between bosons and photons. They're distinct charge geometries and they have distinct mass-energy roles. Of course, any conversion of matter into energy releases a huge number of quanta, and these quanta can interact via their charge geometries to give us not only photons of light and energy, heat, but also particles of matter. And again, because matter is not conservative, it creates a problem in formulating exactly what the processes are that are going on. The energy itself, as radiant energy or charge fields, produces fields of interaction because of their distinct energy momenta within the scalar fields themselves. And again, as I've just mentioned, as we release energy from matter geometries, by collapsing the matter geometries, these energy momenta are released as radiant energies, and they can interact. They can either create fields of interaction within the particle accelerator itself, or they can interact via their charged geometries, weak and strong force, to create various forms of mass energy and or matter within the collision itself. Tetrionic matter specifically, or the standing wave mass energy forms that create matter, again, these are the charged faceted geometries of standing waves of mass energy that are accelerated in the accelerators to create the collisions. The energy of acceleration, or the kinetic energy of motion, is stored as a kinetic energy plus a magnetic moment in the chem fields. And this chem field energy, along with the standing mass energies of the matter geometry, combine to give us a relativistic energy. As we increase the energy of motion, we increase the mass energy of the chem fields and create a length contraction in those mass energy quanta. You can't apply the mathematics directly to the mass energy conversion or collision where the matter is destroyed using relativistic formulation, because it fails to distinguish between mass, energy and matter. It assumes that the matter itself is Lorentz contracted because of the relativistic energies, and by applying it across both the chem field and the matter geometries, you get erroneous estimations of wavelength, etc., for the energies or the amount of contraction of the quanta within mass energy chem fields, when in fact Tetrionics shows us it's only the chem fields that are contracting due to velocity. Because we can do the equilateral geometries of both the chem fields and the standing wave matter geometries, we can in fact calculate for the wavelengths as well as the mass energy momenta and quanta of all particles in motion. It's a difficult process, it's a messy process, but at least we have an accurate understanding of the physics involved at the quantum level and what is going on. And we can calculate and solve for all the physical properties using the Tetrionic mass-energy geometries. Where we have these quantas because of motion, obviously as a field they produce, through the force of interaction, forces on other particles within their fields. In the case of charged fields with electrostatic fields around them, they produce forces of interaction. And likewise with particles in motion, we can create forces of interaction, either Lorentz forces or skin effect, etc. Accordingly, we can also separate static fields into positive and negative charge fields, and the energy within those charged fields, the separated charged fields, is known to us as voltage or electromagnetic forces, potentials, differences. When we separate the charged fields, the electrostatic, magnetostatic fields, into charged fields or voltage sources, we can use these voltage sources when we connect them via a conductor to create a flow of electrical energy or electricity within the circuit. The flow of electrical energy, or the establishment of electrical energy in a circuit, will, after a period of time, also induce energy into particles that are in the field of interaction. So electricity itself is a field of interaction, seeking to equalize itself under the second law of Tetrionics. And as a field of interaction, any charged particle in that field will experience a force on it due to the positive and negative energy momenta in the field itself. As you increase the voltage, you increase the energy momenta in the field. So therefore you increase the force on the particles themselves, the charged particles. This of course creates kinetic energy or chem fields around the charged particles, and they begin to accelerate. There is always a lag between the flow of voltage and the creation of current, but there's a specific relationship, Ohm's law, V equals IR, between the voltage that is applied, the electricity to a circuit, and the current that will flow in the circuit because of that voltage, in proportion to the resistance or the inertial mass of the particles involved. These are all described in terms of electricity, or generally within electrodynamics, and this is where relativity itself really began to be applied in the search for answers that presented themselves as problems or not fully explained within the then current understanding of quantum mechanics or mechanics itself. Obviously, remembering that special relativity was developed in 1905, it's over 100 years ago now, and has stood the test of times since then because it is a mathematical formulation of the processes, or a mathematical attempt to explain the geometry at work that creates the physics. Mathematically, there are a number of places where it is correct, but geometrically it is completely incorrect. And this is what we're showing here. We're showing instead of spherical charges and a mystical unknown electrical force, we can in fact show that the energy momenta of any field will produce a resultant velocity. The velocity is related to the inertial resistance of the mass-matter geometries of electrons in this case. You could equally use mass matters of protons, which would flow in the opposite direction because of the forces that the energy quanta of the separated charges, or the EMF, would exert on them. But they would move slower because they have more inertial resistance or more inertial mass, so that the energy would be unable to accelerate them to a greater velocity. Again, F equals ma. So again, we're bringing Newton's classical formulations of force into quantum mechanics, and at the same time we're showing inconsistencies and errors within special relativity using Tetrionic charge geometries. This picture obviously shows the separation of charges as a dipole, one positive and one negative. When the circuit is completed, as shown on the outside, the conductor itself becomes energized or full of electricity. The electricity is simply the energy momenta of the charges seeking equilibrium. They flow from positive to negative and negative to positive, depending on whether you're doing electron or conventional current flow. In reality, the electricity itself will seek the quickest path to equalize. Once it tries to equalize, obviously it establishes this field of electricity. We can now clearly show what electricity is using the energy momenta, the equilateral energy momenta of Tetrionics. And you can in fact think of it as a magic carpet, if you like. When it's established, the carpet, you could think of it as an escalator or a travelator, probably a better analogy, where half the travelator is moving particles in one direction and half of the elevator at the bottom is pushing the particles in the opposite direction, like two-way traffic or two-way travelator. Depending whether it's a positive charge or a negative charge, a force will be created on any static electrons in the atoms of the conductor. If there's, as the energy is applied of the force from these energy momenta of the electricity, the energy will build up in the chem fields associated with the charged particle. Once you have sufficient energy, the particle will start to move. If it's bound, in the case of an insulator, it will require more energy momenta from the electricity to break it free from its conductor. But in the case of most conductors, there are free electrons or loosely bound electrons where we can accelerate the particles quickly and easily using whatever voltage source we care. So in this case, we can show force equals ma as an expression of energy momenta